Welcome back to Let's Encode. If you're prepping for a senior iOS interview, these are the 10 questions you are guaranteed to face. Stick around till the end. I'll also give you a 6-week roadmap to get ready. Here's the thing. Most candidates don't fail because they don't know Swift. They fail because they prepare randomly. They cram definitions the night before and hope for the best. The ones who actually get the offer follow a structured path. They understand the why behind every answer, not just the what. That's what we're building today. Here's exactly what we're covering. 10 questions, in order of how often they actually come up, from memory management, all the way to architecture and protocol design. Let's get into it. Question 1. What is Arc, and how does it actually manage memory under the hood? Arc, automatic reference counting, tracks how many strong references point to an object, and the moment that count hits 0, the object is deallocated. Instantly. No garbage collector, no pause, no sweep cycle. Here's where most juniors trip up. They call Arc Swift's garbage collector. It isn't. Garbage collection is non-deterministic. It runs whenever the system decides to. Arc is deterministic. The compiler literally inserts retain and release calls at compile time. If you want to sound senior in this answer, don't stop at the definition. Bring up retain cycles and weak references before the interviewer even asks. That's the difference between a junior answer and a senior one. So what happens when Arc fails to clean something up? This is the classic retain cycle. Object A holds a strong reference to object B, and B holds one right back to A. Neither reference count ever drops to 0, which means neither object is ever freed. That's a memory leak, and it's one of the most common follow-ups to the Arc question. Which brings us to question 2, strong versus weak references. A weak reference doesn't increase the retain count at all, and it automatically becomes nil the moment the object it points to is deallocated. That's exactly why you use it for delegate patterns and for closures that capture self. Strong is the default in Swift, and that's fine, most of the time. The problem only shows up when two objects hold strong references to each other. That's your retain cycle from the last slide, in practice. Question 3, struct versus class. This one comes down to one core idea, value semantics versus reference semantics. Structs typically live on the stack, copy fast, and can't be inherited from. They're perfect for models and data you don't want shared. Classes live on the heap, support inheritance, and are reference types, meaning multiple parts of your code can share and mutate the same instance. Know this table cold. It comes up in almost every interview, in some form. Question 4, async and await, and specifically, how we got here. It started with nested completion closures, what everyone calls callback hell. Then we moved to single completion handlers, better, but still fundamentally callback-based. And now, async, await gives us code that reads top to bottom like synchronous code, while staying fully non-blocking under the hood. If you can explain why each step was an improvement, that's a senior level answer. Question 5. Actors. Without protection, two threads can write to the same shared state at exactly the same moment. That's a data race, and it corrupts your data silently. An actor fixes this by guaranteeing only one task can access its state at a time. Everyone else automatically queues up and awaits their turn. You don't write a single lock or semaphore, the compiler enforces it for you. Question 6. MainActor. Anything that touches the UI, UIKit views, SwiftUI state, has to happen on the main thread, and MainActor pins your code there. Everything expensive, networking, parsing, heavy computation, belongs on a background context instead. Swift Concurrency lets you hop between the two safely with await, instead of manually dispatching back to the main queue like we used to. Question 7, MVVM. The view only renders state, it doesn't know where that state came from. The view model formats that state and exposes it to the view. The repository abstracts away the data source. Is it cache? Is it disk? Is it network? The view model doesn't need to know. And the API layer handles the actual network call. Each layer only talks to the one directly below it. That's the whole point. Question 8. Dependency injection. Start with a protocol that defines the contract. Write a concrete implementation of that contract. And have your view model depend only on the protocol, never on the concrete type. That one decision is what makes it trivial to swap in a mock during testing, without touching production code. Question 9, and this is the retain cycle you'll actually hit in real production code, not just in a whiteboard example. A network callback captures self strongly to update some property when the data comes back. If that view controller gets dismissed before the callback fires, self never gets deallocated, it's leaked. The fix is one word: weak self. Now self is optional, safely unwrapped, and if it's already gone, the closure just does nothing. Question 10. Protocol versus inheritance. Protocols give you multiple conformants, they work with structs and enums, not just classes, and they favor composition over a rigid hierarchy. Inheritance gives you shared implementation for free, but you only get one base class, and you're tightly coupled to it. Here's the interview tip. Lead with favor composition over inheritance, then back it up by explaining how protocol extensions give you shared implementation without the downsides of a class hierarchy. Before we wrap up, let's talk about what actually sinks candidates who know this material. Memorizing definitions instead of understanding trade-offs. Having zero real production examples. Ignoring architecture entirely. Communicating poorly under pressure. And having no system-level thinking. Fix these 5, and you're already ahead of most candidates in the room. If you want a plan, here's how I'd structure 6 weeks. Week 1, Swift Fundamentals. Week 2, UI Kit. Week 3, Architecture. Week 4, Concurrency. Week 5, System Design. And Week 6, Mock Interviews, back to back, until the answers stop feeling rehearsed and start feeling natural. If you remember nothing else from this video, know these 10 questions cold, think in terms of production trade-offs, understand the architecture, understand concurrency, and never stop practicing how you communicate the answer, because in a senior interview, that's half the evaluation. If this helped you, hit subscribe and drop a like. It genuinely helps this channel reach more developers prepping for the same interviews. And tell me in the comments, what's the toughest iOS interview question you've ever been asked? I'll answer the best ones in the next video. Up next, a full deep dive into Arc internals. See you there.